With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this problem, we have given that the white coherent light, whose wavelength is ranging between 400 nanometer to 700 nanometer, is sent through the slits of a Young's double slit experiment. So, small d is given 0.5 mm, capital D is given 50 centimeter. There is a hole in the screen at a point 1 millimeter away along the width of the fringe. So you can see over here there is a hole in the screen from the central line. So this is a central line, this is a central line. Which wavelength will be absent in the light coming from the hole? And second is which wavelength will have the strong intensity. So if we want to go for the first option, which wavelength will be absent, then we have to go for a minima to find the absent wavelength. So for minima, as we know that fringe width beta is given as 2n plus 1 by 2 into lambda d by small d, and small d is given as 0.5 mm and capital D is given as 50 centimeter. So it will be 0.5 meter and small d will be 0.5 into 10 to the power minus 3 meter. Okay. And fringe width beta is given as 1 mm, that means 10 to the power minus 3 meter. Now use all these value over here. So put the value of beta, that means 10 to the power minus 3 equals to 2n plus 1 upon 2 multiply by lambda into d is 0.5 meter upon small d is 0.5 into 10 to the power minus 3. So this will cancel each other. The value of lambda will be 2 into 10 to the power minus 6 by 2n plus 1 meter. So lambda can be given as 2 into 10 to the power minus 6, 2 into 10 to the power minus 6 multiply and divide by 10 to the power minus 3 and 10 to the power plus 3. So this will 2n plus 1 meter. So it will be 2000 into 10 to the power minus 9 meter upon 2n plus 1. So this is 2000 nanometer upon 2n plus 1. And we have given the range of lambda is 400 nanometer to 700 nanometer. So if we put the value of n equals to 0, then lambda will be 2000 upon 1 nanometer, that means 2000 nanometer. If we put the value of n equals to 1, lambda will be 2000 upon 3 nanometer, that means it will be 667.3 nanometer. If we put the value of n equals to 2, then lambda will be 2000 by 5 nanometer, that means 400 nanometer. So in the given question we have given which wavelength will be absent. So the wavelength will be absent in the hole on the screen will be the wavelength which will absent in the hole on the screen will be 400 nanometer and 667.3 nanometer. Now if we want to find the second answer, so second question was which wavelength will have a strong intensity. So for strong intensity we will take the maxima. So for maxima fringe width beta is given as n lambda d upon small d. So we have to put the value of beta, and beta fringe width was given 1 millimeter, that means it will be 10 to the power minus 3 meter, into n we have to find lambda. D is given as 50 centimeter, so it will be 0.5 meter, upon small d is given as 0.5 millimeter, which is 0.5 into 10 to the power minus 3 meter. So this will cancel each other. Here lambda will be 10 to the power minus 6 by n meter. We can write as it 10 to the power minus 9 into 1000 meter upon n. So the value of lambda will be 1000 nanometer upon n. So if we put n equals to 1, lambda will be 1000 nanometer. If we put n equals to 2, lambda will be 500 nanometer. If we put n equals to 3, lambda will be 333.33 nanometer. So which is the strong wavelength? So strong wavelength which lies in the range. So lambda strong wavelength will be lambda equals to 500 nanometer, which is the second answer of this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.